Welcome to this tutorial where we review the 10 multiple choice questions from the 2020 Mathematical Methods Tech Active exam paper for the Queensland Certificate of Education. Let's dive straight into the first question. We are given a function and asked about its behaviour as h approaches 0. We can see that both the numerator and the denominator equal 0 when h is 0. So we can't just simply substitute in h equals 0 because our function is undefined at this point. There's no indication in the question as to whether we are approaching from the left or right. But we'll have a look at this in just a moment. To see what happens when h is close to 0 from the positive side, we can enter the expression and substitute. This is much better than entering a value directly for h. Entering lots of zeros in two different places is prone for errors, particularly in the stressful environment of an exam. A single substitution means that h will have exactly the same value everywhere that h occurs. A graph is a quick way of checking if the limit is the same from both sides. Change the h to an x so you can graph it. Then, zoom in on the y-axis and trace the graph. So, the answer to the first question is option C. Question 2. There is a lot of contextual information provided here. For these types of questions, locating the actual question helps you focus on key information. The question is asking for the concentration of hydrogen ions in moles per litre. Now, when you read the information, you'll know exactly what to look for. H is the concentration of hydrogen ions in moles per litre. So we need to find the value of H. The pH of the substance is a measure of its acidity, given by the formula. So, to answer the question, we need to know pH. If a solution has a pH equal to 0.2. Now, we can remove the context and write the equation. 0.2 equals the negative log base 10 of H. In this case, it's quicker to transpose the equation by hand and just evaluate 10 to the power of negative 2. If you're not confident in transposing or using this approach, you can just use the solve command. So the answer is option B. Question 3. The region enclosed by the graph equates to area. We are given information about the boundaries of the region, the function y equals x by e to the x, the x-axis, and the lines x equals negative 1 and x equals 1. The area in question includes sections that are both above and below the x-axis, so the definite integral would therefore include positive and negative values. We could calculate the definite integral from 0 to 1, and then also from 0 to negative 1. Reversing the terminals produces a positive result, allowing us to simply add these two answers. Another way around this is to use the absolute value function. If you use that in the integral, we'll get the answer directly. We can reverse the terminals in the graph by carefully selecting the upper and lower limits. Use the calculator home screen to save these calculations. Then, when you're done, add the two results together. Alternatively, you can graph the absolute value of our function and then determine the area directly with one integral. Our answer is option B. Question 4. A good understanding of transformations of functions and logarithms would help us jump straight to the answer without pressing a button. But let's play a little game of spot the difference. We see that the main difference between the graphs is the location of the vertical asymptote and the axis intercepts. The question says could be. That means 3 of the graphs would be impossible under the given transformations and corresponding restrictions. We could guess some values for P and Q based on the corresponding domain for each. I'll let the log base equal 2 and the translation 0.5. Our graph shows a y-intercept below 0 and an x-intercept between 0 and 1, leaving us to select option C. If we had a little more time, you could use the transformation app to explore. In the case of P, we see no change in the x-axis intercept. That's because P is a dilation. Q is a translation. As Q only varies between 0 and 1, the graph must cross the x-axis between 0 and 1, but not at 0 or 1. This leaves option C as the only viable result. Question 5. In this question, we are provided with an equation for the velocity of an object in terms of t, and asked to identify the displacement time graph for the first 6 seconds. The graphs are a little misleading. The horizontal axis should say time, and the vertical axis would typically say x to represent displacement. Furthermore, we are asked about the graph for the first 6 seconds of motion, but all the graphs show motion prior to 0. Given that all the graphs are labelled the same way, we will focus on the shape. We could use calculus to determine the equation for the displacement time graph. Another option would be to use the velocity equation and study the motion. We can see that the object moves away from the origin rapidly and in a positive direction. Graphs B and D, therefore, have the object moving in the wrong direction. As time progresses, the velocity approaches 0, so our object is coming to rest, its position barely changing. This is represented by graph C. An alternative way to approach this question is to simply graph the antiderivative of the velocity equation. And again, we arrive at answer C. Question 6. This question talks about the rate at which oil is leaking from a tanker. We are provided with an equation for this rate. In the first moment, oil is leaking at a rate of 9,000 litres per hour. So what does this look like after 1 hour? We get 7,368 litres per hour. That is still a substantial leak. Indeed, after 2 hours, oil is leaking out at a rate of 6,000 litres per hour. There's still another 8 hours to go. Even if the tanker had been leaking at this slow rate for the past 2 hours, that equates to 12,000 litres that would have been lost, which only leaves us with option A. Of course, we could use integration. In this case, we know that e to the power of negative 0.2t will be greater than 0, so there are no issues with our graph crossing the axis, aside from which it wouldn't make any sense for the oil to start going back into the tanker. So we can simply integrate from 0 to 10 to find the volume of oil. And so we see the answer is option A. Question 7. This is a straightforward application of the binomial distribution. Shoes are either defective or not defective. Successive events are independent. So, using the distributions menu, we can select binomial PDF. Here, we're prompted for the number of trials, the probability of success, and the required number of successes. So, our answer is option B. Question 8. We're given 3 side lengths and asked for information about an angle. We cannot assume the triangle is right-angled, so the cosine rule is appropriate here. However, there's a really simple geometry fact that the shortest side in the triangle will be opposite the smallest angle. That means we don't actually need to do any calculations. If all the angles are equal in size, such as in an equilateral triangle, increasing the size of any angle means that another must reduce, becoming less than 60 degrees. There's only one option for an angle that is less than 60 degrees, so the answer is A. If you didn't know this little fun fact about triangles, you could use the solve command in conjunction with the cosine rule. So we'll solve 8.8 squared equals 9.9 squared plus 11.3 squared minus 2 times 9.9 times 11.3 times cos of A, and solve for A. So our answer is option A. Question 9. We are given an equation for displacement, and we need to know the acceleration when t equals 3. The derivative of displacement time yields velocity time. The derivative of velocity time yields acceleration time. So we need to calculate the second derivative of s of t when t equals 3. We could have done the derivative by hand. This involves a relatively straightforward application of the product rule, but the result simplifies nicely, so our second derivative is actually quite simple. Now we could see that substituting t equals 3 gives us a fraction of 1/3, the same as we got doing it on the calculator. So the answer is option B. Question 10. Our last question in the multiple choice section is about concavity. Concavity relates to the rate of change of a function's derivative. A function is said to be concave down where the derivative is decreasing, and concave up where the derivative is increasing. This is often referred to as a U-shape upwards for concave and U-shape downwards, convex, also referred to as for concave down. This question wants to know the x-coordinate where the graph changes concavity. If you graph the original function, we can see that this change occurs somewhere between -3 and -1, but there are three options available here. So let's check out the derivative. Now we can clearly see where the derivative is decreasing and where it is increasing. The turning point represents this transition. We can easily locate turning points using the trace option. Our solution is x equals -1.89, which corresponds to option D. Of course, we could also graph the second derivative and find where it crosses the x-axis, or you could solve when the second derivative is equal to 0. But it's always good to look at the graph so we get a better understanding of the question. So that's all for this tutorial. As you can see, in this exam, each question could be done using the calculator. Some questions, however, were much quicker if you just thought about them logically. Check out our other tutorials with some sample exam questions, worksheets and revision sheets to help build practice and confidence in tackling exam-style questions. Thanks for watching.